So today we are going to talk about the context variables in Apex triggers. We will be discussing about what are context variables, why are they used, and how do we use these context variables in different, or how do we use rather different types of context variables in our Apex code, right? So let's quickly get started, and let's understand in a brief what are context variables. So these context variables, as we discussed earlier while we were talking about basics of Apex triggers, we discussed that these are system defined variables. And so very important thing, these are system defined variables available during trigger execution. So these are the variables which are available by default. These are system defined variables. You do not need to write these variables, or you do not need to define these variables. These are predefined variables and can be used while writing an Apex trigger. Okay, so these are available only for Apex triggers. You cannot use these variables in other Apex code. These provide access to record data before and after change. So primary reason for these context variables is to provide you access to the data which is associated to the record in context or associated to the trigger execution that is happening. All right. So they give you access to the record or the set of records which are getting executed through that trigger, and it gives access to both before and after change. All right. This also gives you access to to let you know which operation initiated the trigger. So if it is an insert, update, delete, undelete, which operation. So there are different types of trigger events, right? In case during the execution of the trigger, you want to understand that this trigger code was initiated by which event, and based on that you want to control your logics, you can do that using this. And it enables bulk save and conditional trigger logic. So as I said, if you have access to different information related to that particular trigger execution, you can control your logics accordingly. And this is basically the foundation for scalable trigger design. So it kind of helps you design your bigger trigger. So if you're writing a trigger which is a very small one just for one particular event, then you can still go ahead and write it. But if you are thinking of bigger triggers, like something that gets executed in all DML events, then these context variables are very handy in helping you design your logic for those broader triggers or the bigger complex triggers. All right. Okay, so the next thing that we are going to talk about is we are going to go and we are going to start discussing about each of these context variables one by one. The first one is the Trigger.new, which is the most common context variable used a lot of times. So we'll quickly understand what is it. So this is basically the current version of records in the trigger context. So the current version of the record, when the trigger is getting executed, the current version of that particular record or the record that is getting inserted or updated at that point of time, that record is stored in this context variable, which is Trigger.new. All right. And where is this available? This is available with before insert, after insert, before insert, after insert, before update, and after update. So if you notice this is only available with insert operation and update operation. It is not available with a delete operation. Okay, so the concept is very simple. If there is this database and if there is a record which is trying to get into the database, Trigger.new is the value of the record before it goes and gets saved in the database. All right. So the value of the record, even if there is an insert operation or an update operation that is happening, Trigger.new is the value which is there available before the record actually gets saved in the database. So that is what Trigger.new contains. All right. Now let's have a quick look at the code, a sample code for this. So you can use Trigger.new and you can write a for loop to access the values, all the records which are part of Trigger.new. So here Trigger.new is the list of records which have initiated the trigger, and you can then iterate it through a loop, and then you can define a variable and then do whatever you want to do on those records, right? So if you look into this particular code here, this is what we are doing, right? So we have defined an account ACC, and basically it iterates through all the values in Trigger.new, and after that it would assign a rating to that particular record. All right. Now, important thing is when you are accessing this Trigger.new, and if you are making or updating anything, this is enough. You just say, ACC.rating is equal to this. you do not need a DML statement after this. So, after this, you don't have to write an insert or an update statement. Not required. All right. So in case of an insert or update event, if you're using Trigger.new and if you have updated the value in Trigger.new, because Trigger.new is already the value before the record gets saved, right? So anyhow, the record is going to get saved. You have set the value before the save. So you actually do not need to go and write additional DML statements. So no additional DML required. So this is the thing. All right. So that's about our Trigger.new. Now, similar to that, we have Trigger.old, but it is slightly different. What is Trigger.old? Trigger.old is the previous version of your records. Okay, so before the operation, the previous version of the record. What is previous version of the record? Now, before I get into that, let's understand where it is available, and then I think it will be easier for you to understand what exactly it means and how is it different from our Trigger.new. So if you look at it, it is available with before update, after update, before delete, after delete. So this is only available with update and delete operation. It is not available with insert operation. No, it's not available with an insert operation. It is only available with a before and delete operations. All right. Now, quickly, let's understand what is the key difference. So usually what would happen when we are trying to insert a record, there's a completely new record which is getting into the system, right? And when we are trying to delete a record, there is a record which is actually getting deleted, thrown out of the system, let's say. All right. So the Trigger.old is basically the value of already saved record. So before the trigger started, what was the value of that record? Now that scenario comes only in case of update and delete. That is not, that is something which does not happen in case of an insert operation, right? Because insert operation is completely new record which is getting into the system, right? So Trigger.old will only apply on update and delete. So update would mean when there is let's say there's a record which is getting updated, so this update will have an old value and a new value, right? So the new value which is getting into the system at that point of time gets stored as Trigger.new, and the old value gets stored as Trigger.old, right? So here both the things will be applicable. This is for update operation, right? However, with your delete operation, you only have old value because it will never have a new value. There is a record which is being deleted. So before the delete operation started, the value which was stored in the system, that is going to be Trigger.old, right? So for update operation, you will have both Trigger.new and Trigger.old, because update operation will have two versions of the same record, which was before update and after update. In case of delete, you will only have Trigger.old, and in case of insert, you will have only Trigger.new, and update has both. All right. So that is the thing. Let's quickly have a look at the code for Trigger.old. So for Trigger.old, this Trigger.old. So this is the code that we have. Now Trigger.old. Okay. It's pretty similar to that. It's very, very similar. The code is very similar to what we had written for Trigger.new. But the only difference you see here is here I've tried to do a system.debug. Okay. Now you cannot use Trigger.old. Trigger.old values are kind of read only. So you cannot just go and say something like you cannot go and update the value of this record here because it's an old value. So it's a read only. So Trigger.old values are read only and cannot be edited as part of that trigger. Correct? So that is another key difference here. All right. So that's it. So the next one that we're going to discuss is the trigger context flags. Now these trigger context flags are basically, it's not just one context variable, but a combination of context variables, which I have put together in the same slide just for to make it simple to understand, because all of these have pretty similar functionality or use case, right? So this Trigger.isInsert, Trigger.isUpdate, Trigger.isDelete, Trigger.isUndelete, Trigger.isBefore, and Trigger.isAfter. These are context flags, or what these are kind of Boolean flags which can be used to determine which trigger event initiated that particular trigger execution. Now, why are these used? In case you have multiple logics written inside a trigger, or if you have a single trigger which is being called on multiple events. So if you see, if you have a same trigger that runs for multiple events, you can use these Boolean flags. So it gets true, it becomes true if when the trigger has been executed for that particular trigger event, right? So if it is an insert, if the trigger was initiated by an insert operation, then Trigger.isInsert will become true in that case, right? So what we can do, we can use these Boolean variable values to determine which event initiated the trigger, and using that we can control our logic. So for bigger complex triggers and trigger logics, this becomes very useful and very handy. So let's have a quick look at a snippet of the code. I've kept it very simple. So let's say you have a trigger which gets executed on all these 4 events, right? On insert, update, delete, and undelete. But you want to execute different logics for each of these events. Then what you would do, you can do something like this. You can say if Trigger.isInsert, then do this. I've just kept it very simple. I've just used a system.debug, but you can write a full-fledged code logic there. If it is a Trigger.isUpdate, so basically, what does this mean? It means that if this trigger was initiated by an update operation, then you can do this. If it was initiated by a delete operation, then do this. If it was initiated by an undelete operation, then do this. So this way, what you are doing, you are basically covering all different scenarios for your trigger logic execution, right? And you can have different logics executed for different events. All right. Now other than these, there are these Trigger.isBefore and Trigger.isAfter also. So if you want to be more specific, like here I have just said, if Trigger.isInsert, basically what it will do, it will execute this piece of logic for all insert operations, right? However, now if I want to get I want to get more controls on it, I want to execute a logic only in case of a before insert. Then how can I do that? I can simply write if Trigger.isBefore and Trigger.isInsert. All right. So now what does this mean? This means a before and an insert. So it should be a before insert trigger, and then you can again similarly you can just go ahead and write your logic, right? So that's about the Boolean trigger context flags, which can be used for determining which trigger event initiated that trigger execution, and based on that you can go ahead and write your logics. Now the next one that we're going to talk about is the Trigger.newMap. Now what is Trigger.newMap? Trigger.newMap is basically the map of record ID to the new version of records. So this is kind of IDs mapped to Trigger.new. So if you have Trigger.new here in this box and IDs of all the records, this is a map. All right, this is a map of these things. So earlier we have discussed about it, while we were discussing about the different data types available in Salesforce. Map is a data type. So map is basically when you maps, the key value pairs. So here, this is the key and this is the value set, right? So this is the key set and this is the value set. All right. So now Trigger.new by default is a list. Okay. This is a list. And when you use a Trigger.newMap, Trigger.newMap is a map of IDs to the records. And this is basically a map of IDs to the Trigger.new. All right. Now, why do we need this? Trigger.new is useful when you're simply trying to work with all records in a Trigger.new in a trigger, right? So if you have to execute same thing for all the records in a trigger, then Trigger.new is of course helpful. All right. However, if you have to execute certain logics and if you have to do some certain things on specific records inside the Trigger.new, then this Trigger.newMap gives you the option to retrieve a specific record from the Trigger.new using the ID, and that's what we are doing here. So if you see here, I'm trying to retrieve the record from Trigger.newMap using the ID. Now this is something which you cannot do in Trigger.new, all right? And that is the reason why we are having this option of using Trigger.newMap. So Trigger.newMap gives you additional flexibility to go ahead and retrieve a specific record using the ID. Because it's a map, you can use the ID, retrieve the record, and then work with that, use that for your logic execution or for building your conditional logics, etc. So that is there. All right. Similar to Trigger.newMap, we have another one which is called Trigger.oldMap. The only difference between Trigger.newMap and oldMap is Trigger.oldMap is a map of record ID to old version of records and not the new version of records. So which would mean that it is available with update and delete operations, right? because old version only exists for update and delete records, right? And the use case or the use of this is going to be pretty similar to what we discussed about Trigger.newMap. You will have the flexibility to retrieve an individual record or a specific record using the ID. So you can use this function Trigger.oldMap.gets, and you can supply the record ID here, and then you can use the specific value retrieved for any of your logic execution. All right, so that's what a Trigger.oldMap does. All right, now we'll try and understand for this Trigger.newMap and Trigger.oldMap. Actually, if you see this, there is a very specific use case, or there is a very specific requirement. So the moment you start working a little bit advanced triggers, etc., you will see the use of Trigger.newMap and oldMap a lot more. Okay, and I'm going to talk about one particular scenario here, which is very common. So this is basically about field change detection, right? So if you are trying to check if a record's values have changed during that trigger execution, if the record's value or a particular field value has changed, right? Then what you have to do, you have to compare this, you have to compare both the things, Trigger.new and Trigger.old, right? So if there's a record being updated, let's say there is a, sorry. What am I doing? Okay. So let's say there is a record, all right, and in this record there are some fields, right? Now when the trigger gets executed, you specifically want to check the record got updated, it's fine. You specifically want to check if this field got updated or not, right? Now how do you do that? So what you have to do in this case, you will have to compare the new value versus the old value, right? Now the challenge is, if you're trying to execute your code through Trigger.new, then you need to retrieve specific old value for that record only, right? So that is where this becomes very useful, this concept of Trigger.newMap and Trigger.oldMap. So you can be iterating your trigger through Trigger.new, and on a specific record you can use the ID of that particular record and then retrieve the old value of that, and then compare that, okay fine, if the new value and old value are same or not. Okay, so that is the thing. Now if you look at this particular example, see, I am iterating this through Trigger.new, all right, and what I'm trying to do is I am trying to do a comparison somewhere to check if the old value and new value have changed, right, on the annual revenue. So new value of annual revenue is of course part of the Trigger.new, right? It's an update operation basically. And what I'm trying to do is I'm trying to check if the old value and new values have changed. So the new value is available as part of this record because this I'm iterating through Trigger.new. So of course ACC contains the new value, right? However, I also need the old value of the same record. Now how do I get that? Because I have already initiated my loop through Trigger.new. So what I'll do, I'll define another account record. So there is another version of the record or another variable which I have defined, which will retrieve the old value of the same record using the ID of this record. All right. So now what I have ACC, which contains the new value, and I have old ACC, which contains the old value. So I have two variables. All right. Now, since I was iterating this loop through Trigger.new, it was difficult for me to retrieve this if Trigger.newMap and Trigger.oldMap were not there. But now since I have that, I could simply use the ID of this record, retrieve the old values for the same record, and then it becomes super simple for me to compare ACC.annual revenue not equal to old ACC.annual revenue, and then you do whatever you want to do. For example, here I have tried to update the description, or you can do any sort of logic execution there. So this is a very, very important use case which is used very frequently. So this field change detection, it is basically required anytime you want to check exactly what has changed. Okay, so this can also be used for preventing unnecessary execution of the entire trigger if nothing has changed. Sometimes there will be an update but nothing has actually changed, and you have a long trigger logic, so you do not want to execute everything if nothing has changed. So that sort of thing. So this basically, the use of this kind of functionalities, or checking these field changes or detecting the field changes, helps you avoid unnecessary processing, and eventually it improves performance and prevents recursion bugs. So these are critical things which can be prevented or which can be improved on your trigger if you use these logics.